The one sample z-test is called one sample because we're only talking about comparing one sample from one population. We're not talking about comparing two groups to each other. So if you think back to our early discussions of sources of uncertainty, we're only thinking of uncertainty that exists because we sampled from a population. We're not comparing two groups. This fits nicely into the framework for hypothesis tests that we've set up. The null hypothesis is that the mean of the population is equal to some particular value, and the alternative hypothesis is that the mean is not equal to that particular value. We have a test statistic. Why this particular test statistic? Because as we've derived, thanks to the central limit theorem, this test statistic is known to follow the standard normal distribution that we have right here. And so if we observe a particular value of z and say we wanted a two-sided p-value, and as we discussed, it doesn't matter whether you give one or two-sided as long as you say which one it is. The p-value is the probability that the test statistic would be at least as extreme as actually observed. Of course, the problem is that we don't really know what this sigma is, the population variance is in any particular context. So this assumption here is that we know the population variance. Another assumption here is the sample size is large enough that normality is reasonable. The more normal the population distribution, the smaller sample size you need for that to be true. And we're assuming that we're sampling independently, that the fact that I included one particular observation in my sample, one particular unit, has nothing to do with whether any other particular unit is in my sample. Now, if I don't know sigma squared, in other words, in almost all cases, I estimate it. And this slide looks just like the other one in many ways. The null hypothesis for the one sample t-test is still going to be that the mean is equal to some particular value. The test statistic, which we'll now call t, looks just the same except we've substituted s for sigma, and s is an estimate of sigma. And the reference distribution looks a lot like the normal curve, and it almost is the normal curve, except it's actually called the t-distribution with n-1 degrees of freedom. So the t-distribution looks like the normal if it has a high degrees of freedom, but if you have a little bit less information, if the sample size is smaller, then the t-distribution has a little bit wider. Its tails are bigger. In other words, for a particular value of the test statistic, the p-value will be a little bit bigger from comparing that t to the reference to the t-distribution than if we compared it to the standard normal. And here I'm assuming that you've seen some of this material before. So the one sample t-test assumes that the population distribution is normal. Now this is a departure from what we said about the z-test. The z-test, you don't have to assume that the population distribution is normal because the central limit theorem is enough. For the t-test, because we don't know what this variance is, this entire quantity no longer necessarily follows a normal distribution. For big N, when the degrees of freedom are very high, it'll follow a t-distribution that almost looks like a normal distribution. But if you think about this quantity, N is just some fixed number. Mu naught is just some fixed number we made up. Y bar is something random depending on which sample we get, but S is also something random depending on which sample we get because S is an estimate of sigma based on the sample. So now both the numerator and the denominator of this test statistic have some variation, have some uncertainty, and for that reason, even with the central limit theorem, we can't quite say that this distribution here, the reference distribution, is going to be normal. We say it looks t. But even in order for it to look t, we have to make this assumption that the population distribution itself is actually normal. Now, how important is that assumption? Turns out not very important, and that's something that we'll come back to. And we're still assuming independent sampling from the population.